Hello and welcome back to our Python programming course. Today we'll see the solution of the homework exercise of section 4, basketball free throws. Okay, so let's remember what the assignment is. This is the image of the free throw. This happened due to a fall, and the victim team has the chance to shoot a free throw. So a free throw worth is 1 point, and we had this data. We've been supplied for the two additional in-game statistics: free throws and free throws attempts, and we need to create three graphs, three plots to the following sites: free throws attempts per game, accuracy of free throws, and player playing style, 2-pointer versus 3-pointer preference, excluding free throws. So each free throw is worth 1 point, and the data has been supplied in form of vectors, and you have to create two matrices before you proceed the analysis. So we gave it a hint, the formula for the part 3, the points minus free throws divided by the field goals, and fill in blanks Python notebook. Let's take a look on this. Just a second. Here it is. This is the data, the Jupyter notebook with the data sets. We have the seasons, we have the players, and the arrays of free throws, and the arrays for free throws attempts. So our first assignment here is to build a matrix using these arrays. So let's have a look on the filling blanks Jupyter notebook. So first of all, we need to import numpy and matplotlib.pyplot. So okay, all right. So second, we have the data, that the same data that we had here. Just put it into one cell, make it easy. Let's execute them. Okay, and the dicts. This is for the purpose of filtering the matrix based on the year and the name of the player. Okay, it makes it easier to filter using the year, the actual year, instead of the index and the name of the player. So we pass the name of the player or the year and receive the index, so we are able to filter the matrix as we saw on the lecture. Okay, same approach. All right, so here it is. We have to bind the vectors to form the matrix. Remember, we just import the numpy module and we use a function from numpy. So numpy has we imported as np as standard definition of the import function of numpy, and we'll make an array, a multi-dimensional array of the other arrays. Okay, so here we have built the matrix, the array of arrays, and then we don't need anymore each individual array, so you can remove it from the kernel. So we'll delete all the arrays, unidimensional arrays. So same approach here. We have free throw attempts and np.array, and same thing with the excluding the variables from the kernel. Okay, so let's run that. Okay, and let's have a look in our matrices. Okay, here the first one, and the attempts. Okay, great. Now we will create a function to plot the data. It's a generic function that receives the data and the player list. If you pass, if we didn't mention, we assume that the parameter is the players. Okay, and here, as you saw in the lecture, we will have a dictionary of colors and marks to make easier to see on the plot a lot of players all together. Okay, so this is not required on our exercise, but let's have a look on the function myPlot of the free throws to see any anomalies on the dataset. Same thing here, myPlot, and let's run. Oh, just a second. We must create the function first, of course. All right. Okay, here it is. The data of free throws. Okay, same color scheme and mark scheme that we saw on the lecture, and the same thing of the attempts. Okay, seems pretty normal, the data, no anomalies or visible anomalies. So let's move on. Part 1, we need to investigate the free throw attempts per game. In this part, we will need the game matrix that we imported, that we used on the lecture. So we just copy the arrays in here, and then the creation of the matrix, pretty much the same approach that we used before. Okay, let's rerun that. Okay, so now we have to plot the ratio of attempts, free throw attempts per game. So let's copy the name of the matrix, free throw attempts. Okay. Oh, not okay. All right. And now divided by games. Okay. And let's run that. We have a problem here because one year a player didn't have any game, and that's the problem. But that's the problem. We can move on. Let's take a look on the performance of Chris Paul. Chris Paul has very few attempts comparing to other players. One of the least performances on attempts. And let's remember this player because we have an interesting insight in the next part of the challenge. Okay, so let's move on. Part 2, free throw accuracy. In this part, we don't have to use any previous data. We just need to divide the free throws attempts by free throws, right? This is just the free throws divided by free throws attempt, and that's the way we measure accuracy. Okay, same thing here. A little warning. Okay, let's have a look. This is a measure between 0 and 1. That stands for percentage. So it's accuracy, and you can see the best players are closer to 1 and the worst are closer to 0. Okay, so let's have a look at Chris Paul again. Chris Paul is one of the highest accuracy of all players In fact, he was the most accurate player from 2014, and this explains, one cause of this behavior might be due to he has very high accuracy and very few shots on free throws. That's could be explained by some I don't know, maybe because he was so good, the other players avoid to make falls on him, so he throws very few free throws. But probably if he have more chance to shoot free throws, he uh, he will make more points. So the other team try to avoid him, put him on the situation of shoot a free throw. Okay, this is interesting. This it's what data is telling us. And another interesting here is the performance of Dwight Howard. It's very poor performance in free throws. It's close to 0.5 in 2011. Very poor performance. And this is strange because if you remember in the lecture, we have a very high accuracy of field goals of Dwight Howard. So we must investigate what is happening with this so poorly performance on free throws. Let's try to answer that. Okay. Here we are already imported the field goals and field goals attempts of the lecture, and plot them in the same way we did with the free throws. So field goals divided by the field goals attempts to measure the accuracy, to remember Dwight Howard performance. Let's see, a very high performance. Okay, very close, not close to 1, but is higher than the other players, and definitely more close to 1 than to 0. Okay, and what could explain this behavior? Well, let's think. If a player like Dwight Howard is not good in shoots from a certain distance, as we can see in the field goal data, one explanation could be that he's a very tall player that just dunks the ball into the net, and in that way he has a very high accuracy because he hardly miss a shot. And but the same way he has very poor performance on the throws, okay, in shoots from a certain distance. And the third part of our analysis is perfect to see this behavior, because we will investigate the player style, the patterns of player style based on how many points each player scores in average by attempt. Okay, so again we will need the points matrix that we used on the lecture. All right, we run that, and we must fill the blanks here. Points minus free throws. So we would discount the 1 points that for free throws from the points, and then divided by the field goals. All right, so that's it. Let's see. All right, so this matrix plotted here shows that the numbers are between 2 and 3. That makes sense because in the rules of the basketball game we just can have the 2 or 3 points in field goals. We already excluded the 1 point, so you cannot have the 1 point messing up our average. Okay, so let's take a look. Dwight Howard is almost 2 his mean. It's a little bit difference in some years, but in the mean is almost 2, so we can say for sure that he is not a distance player, so he doesn't shoot for 3-pointer, for instance. So the other players, you can see there's different patterns here. Sometimes they change a little bit their styles. For instance, John Johnson is very interesting one. He changed it a lot in 2010, more close to 2, and then a lot of improvements on 3-pointer, increasing his mean to closer to 3. Okay, so that's very interesting way of combining different informations and see patterns without knowing the game itself or the players, or knowing very deep understanding of how the games work. So in this graph was very clear that we see Dwight Howard, how he's a good player close to the net and not so good player from the distance and with free throws. And this is very clear. It pops out here in this graph. Okay, so that's it. We made all the 3 requirements of this challenge and extract very good insights from it, and I hope that you enjoy it, and see you next time.